Let's put all this together. I want to do an exercise that combines referencing some Rhino objects, passing some data around, doing some data conversion, and adding some inputs to the definition as well. What I'm going to do is I'm going to start with a surface here in Rhino. I'll make that with this surface from 3 or 4 corner points. I'm going to click that and I'll draw a couple of points like that. I'm going to select the surface and I'm going to give it some definition so I have some more control points that I can push and pull. I'm going to rebuild it. 7 by 7 is fine. Okay. Then I'll turn on the control points. I'm going to grab a few of these and just start pulling some up and down, so I have something to play with. That looks decent enough. Remember how to reference that into Grasshopper? We go to Params, Geometry. In this case, it's Surface. We actually could use Surface, BREP, or Geometry, but let's go ahead and use Surface. Right click on it, say Set One Surface. There we go. Now notice one thing in the case of the surface. We have this sketchy looking presentation here, and that's really because Grasshopper is trying to draw a preview of the surface on top of the surface itself. Let's try something. Let's move the surface that we have referenced now in Grasshopper over a little bit. The Rhino surface is going to stay where it is, but the reference will move over to the side. To do that, I need to transform it. I'm going to go to Transform, Euclidean, and Move. We haven't looked at Move before. Let's see what it needs. I hover over G and I see this generic geometry component. That can be anything. It could be any sort of geometry data type. I'll plug the surface into there. The second one is asking me for a vector, a translation vector, a direction, and a magnitude. We haven't looked at vectors too much in detail, but we can probably find something here in vector. And then we have a vector area. And here I have a couple of just basic directions. Let's move it in the x direction. Now it's being moved a little bit. Here in F, there's only one unit. So let's right click on F, set number, change that to maybe 100. Now we have them side by side. To clear this up a little bit, I'm going to select the surface param here. I'm going to right click it and turn the preview off. Now we have surface here. We've moved it over so that we can work with it and see it properly. Now remember that while it's fine to input the values into the inputs themselves, it's going to be a little bit more explicit and clear if we actually use, for example, a slider or a panel. I'll bring a panel here. Because we're pros, we can double click on the canvas, do quotes. I'll put in here 100, press enter. Now everything's pretty explicit. Let me move this a little bit over. Maybe I want to say what is actually happening with the surface. I'm going to do a Control G to group it. Maybe I'll add a note like reference surface from Rhino. All right. What I'd like to do, visualize the height on the different points of the surface. In order to do that, I have to think, well, I need to eventually have some points where I can understand their z value. And at the same time, I need some way to convert those z values into colors and eventually paint it all. We're going to go through a couple of steps here to do that. I know that meshes themselves can actually accept colors on their vertices. So I'm going to convert this surface to a mesh. And I'll do that in a very quick way. I'm going to go to Params, Geometry, Mesh. I'll pass the surface in there. And as you can see, we get this sketchy drawing again because Grasshopper's trying to draw two things on top of each other. So I'm going to select here the move. I'll right click on the canvas and I'll say preview off. Now we have a mesh representation of our surface. And I'm going to turn the grid off in Rhino. Now if I select my surface and I change some of these control points, I have a corresponding mesh representation over there. I'm not exactly sure how the component meshed it. I just let Grasshopper do it. If we wanted more control over the meshing, we'd go to Mesh, Utilities, Mesh BREP, or in this case, because it's just an untrimmed surface, I can use Mesh Surface. For now, let's see how this takes us. I'm going to also show you something here that we can display the mesh information by going to Display and saying Preview Mesh Edges or Control M. We can see that we have a pretty interesting meshing here where there's more curvature or change in elevation, seems to be more triangulation or more cells. It's a pretty uncontrolled meshing. Grasshopper's doing it by itself in the background. Again, mesh BREP or mesh surface if you want more control over that. For now, we'll stick with that. Now I need to get access to the vertices of the mesh. So I'm going to deconstruct the mesh. I'm going to go to Mesh, Analysis, and Deconstruct Mesh. And I'll put that over here. Now I have access to the vertices, the faces, the colors, and the normals. And what I wanted to do is I wanted to paint this mesh based on the height of each point. So I have to look at the vertices. What I'm really looking for here is the z element of this point. Actually, after I deconstruct the mesh, I need to further deconstruct the vertices. I'm going to go to Vector, Point, Deconstruct. Now I have the x, the y, and the z of these vertices. What I want to do now is I want to take these values and actually convert them into colors. How are we going to do that? I'm going to use one of the inputs that we haven't looked at yet. So here in params input, we saw colors, but we have this other component here, gradient, which we didn't take a look at, and I'm going to introduce now. The color gradient allows you to input some values and eventually convert them into colors. Let's take an example here. Imagine that L0 is 0 and L1 is 1. L0 corresponds to the left side of this gradient and L1 corresponds to the right side. That means that if I put a value here t of 0.5, somewhere in between 0 and 1, I'm going to get a yellow color coming out of here. If I put a 0.25, I'll get something orange, and if I put a 0.75, I'll get something blue. So that's the idea. You define what represents the left and the right side of this gradient, which values, and you pass the remaining values, or the values in between that, into the lowercase t. If you right-click here, you have a bunch of different presets. You can also create your own presets and save them here. I'm going to switch here to this green, yellow, and red, something like that. And we can also squish this up. The way that we're going to convert to colors is to pass the z values to this color gradient. Pass the z here. But L0 and L1 are between 0 and 1, and the heights of my points on this mesh are higher than 1. I need to somehow create a minimum and a maximum of whatever values I have in this list. I need to create something. In this case, I need to create a domain. How do we do that? Well, let's go to Maths and the domain area to see what we have. We can construct a domain, but we don't know what the actual minimum and maximums are. In that case, a good component for that is bounds. It looks at a list of numbers, and it'll give you a new domain with the minimum and maximum. I'll do that. I'm going to put that right over here, and I'm going to move these over a little bit. I'm going to pass the z into there. As a result, I have a numeric domain that goes from negative 8.15 to 12.06 in my case. Negative 8 is the minimum z value, and 12.06 is the maximum z value. All right. So I have what I should be plugging into L0 and L1. But wait, here I have a domain, and L0 and L1 are asking for numbers. How do I go from this domain? I essentially need to get negative 8.15 separate from 12.06. Again, we're going to deconstruct the domain. Here in Maths domain, we also have deconstruct domain. Now I get the start and the end of the domain separate, which I can plug into L0 and L1. Now I have a new list of colors from the values of the height. How do I paint up the mesh? Let's go to the Mesh tab, and here in Primitive, we have a component called Mesh Colors. Let's see what it takes. In M, a mesh. We have the mesh, that's great. And in C, some colors. Let's plug in the colors, and then let's plug in the mesh. Something interesting is happening here, but I have a lot of points on top that I can't see too much what's going on with the mesh. I'm going to select the component that has the points there. This is the deconstruct mesh over here. I'm going to right click on it and turn the preview off. Now, what we have here is a height map of our surface. At the moment, I'm just going to turn off the mesh edges. So this is in display preview mesh edges. I can see that a little bit better. Let me expand this so we can see the whole definition. We start with the surface. We convert that data type of a surface to the data type of a mesh. In order to get access to the information of the mesh, we deconstruct it into vertices, faces, colors, and normals. The vertices themselves are again deconstructed so that we can get access to the z value. We generate a domain from the minimum and maximum z values. We deconstruct that to eventually create a color gradient that we can plug in to a mesh colors component that takes the original mesh that we had and passes it all the colors. For each vertex on the mesh, we have a corresponding color that corresponds to the height. Now, for example, I can go back to my original surface, turn on the control points, and start to, for example, move things around. And we have this little interactive definition that allows us to visualize the height around different parts of this surface. Notice that we could also, for example, measure the normal. We could see how off of vertical each of the normals on this mesh are, but I'll leave that as an exercise to the viewer.